t going from 0 to infinity, well, 0 is not a problem. E to the 0 is 1. That's going to work. It's the infinity part that's a problem. So if I have infinity plugged in for t, what's the range of values for s for plus 1 that makes sense? That's the important question, right? So I'm going to want to constrain the real part of that number, s plus 1, to be bigger than 0. If the real part of that number is bigger than 0, then this thing will converge to 0. If that converges to 0, then I have a simple answer. It's just the answer in the bottom. It's in the bottom, so I have to put a minus sign. That kills that minus sign, and so my answer is 1 over s plus 1. Easy, right? And we will say that the Laplace transform has a functional form, 1 over s plus 1, and has a region of convergence, the real part of s bigger than minus 1, just solving that inequality for the real part of s so I can draw it on an s-plane. So we'll associate then with this s transform a picture which we will commonly call the pole zero pattern. It's just a picture of the s-plane which shows me the singularities, the poles and zeros of the Laplace transform, and the region of convergence. So there's a single pole. There's a pole at s equals to minus 1, so I indicate that by the x. And I have a region of convergence, which I'll illustrate here with the gray area. So it converges for all values of s that are in the gray area. Okay? Easy, right? Trivial. Okay, so now you get to talk to your neighbor. Okay, turn to your neighbor. Say hi. And figure out the Laplace transform of a slightly more, but not very complicated function. So what's the answer? Everybody raise your hands, show some number of fingers equal to the number of the correct solution. Wonderful. The universal answer, I think it was universal, was 1. So how'd you get 1? What do I do? How do I find the Laplace transform of the top function?
And then the only question is the region of convergence.
Precisely. So what I do is just stick it in the formula, do it twice. Laplace transform, like the z transform, is linear. It will turn out that the Laplace of a sum is the sum of the Laplaces. So if I simply stick the formula, if I simply stick the expression for x2 into the definition, you can see it splits into 2 pieces. And I get two parts, 1 over s plus 1, just like I got for, so the first part looks just like x1, the first example. The second one looks almost the same, except there's a 2 where there used to be a 1. Shockingly, it changes one of the 1s into a 2. And then the only issue is where's the region of convergence. So this part converges if S is bigger, if the real part of S is bigger than minus 1. This converges if the real part of S is bigger than minus 2. So they both converge if the real part of S is bigger than minus 1, right? If I'm in the region of S where both the first part and the second part converges, then I'm fine. Okay?